Good afternoon. I am Jung Jong-jin, who will make a presentation on ocean transformation, renewable energy, and floating offshore wind. I would like to thank the organizing committee of WOF for inviting me, and my thanks goes to the participants as well. So I was in charge of developing floating offshore platform. And today, through the presentation, I will share the case studies. This is the content of my presentation. It includes 5 parts. First is reason for renewable energy. We all know that renewable energy sources will have to be used, but the amount and how can differ. So the first reason, to explain the reason why we have to develop floating offshore wind platform, let's go back to the basics and explain why we need renewable energy. The reason why we need renewable energy is to have a safe power source. By safety, it means we need to prevent global climate change. The biggest contributor to the global warming is fossil fuels. Greenhouse gas emissions coming from fossil fuels will have to be addressed. So that's why we need renewable energy. To talk about climate change more, we say global warming. And I think global warming is not an appropriate term to describe the recent phenomena. I think we need to call it as a climate crisis or boiling earth. We suffered a very scorching hot weather in the summertime, and I think the globe is now warming. It is boiling. There's an intergovernmental panel on climate change, IPCC. They had published an important report last year. It was the 6th assessment report of IPCC. In the report, they mentioned since the industrialization, since 1850 to 1900, the global surface temperature rose by 1 degree Celsius, and they issued a warning on the speed of global warming. To cap the global warming to below 1.5 degrees Celsius, then we need to take an unprecedented scale of the challenge. The report says that the science is clear. To cut down GHG emission by half by 2030 and to achieve net zero by 2050, we need to make efforts. And if not, if we fail to take appropriate measures, then the global warming will go up to 2 degrees or 3 degrees Celsius. COP, Conference of the Parties, 28th meeting was held last year in Dubai, and they declared that we need to transition away from the fossil fuel. Because fossil fuel is the biggest contributor of global warming, the COP suggested that renewable energy sources will have to be used 3 times than now. So let's look at the feedstock or the root cause of GHG emissions. One biggest cause is the power generation. Greenhouse gas emissions come from power generation, which is followed by transport and so on. If we think about the electricity part, in order to produce the power, we emit another GHG. So we need to think about way to produce electricity without emitting any GHG. There are many alternative energy sources, but today I want to focus on wind energy, offshore wind especially. According to International Renewable Energy Association, the energy consumption by 2050 will have to be converted to electricity. But in order to produce that electricity, 90% will have to be from renewable energy sources. So in the future, we will need more energy, and the electrical power will have to come from renewable sources. If you look at the chart here, the ideal scenario is to tap the global warming below 1.5 degrees Celsius, and renewable energy sources is emphasized. And again, hydrogen is gaining a lot of attention here as well. Renewably sourced green hydrogen is important. All in all, electricity, hydrogen, and other sectors, renewable sources of energy will be used more and more. So among the renewable sources, let's see what kind of sources we have. We have wind and solar. And the use and demand will increase until 2050. If you look at the slide in the middle, then the wind energy will have to power 10,000 gigawatts. And to achieve that goal by 2030, around 3,500 gigawatts of wind power will have to be generated. So that was the global picture. Let's look at Korea's situation. In May this year, the government published 11th Basic Plan for Supply and Demand of Power. If you look at the plan, the renewable energy by 2030 will have to be used by 21.6%, and by 2038, the amount will have to be increased by 32.9%. The goal is quite ambitious. The thing that we need to focus on is that coal-based power plant the share of coal-based power plants should be reduced. By 2030, the target is 18%. It will not be easy. And the share of non-carbon power generation will have to be increased. So let's look at the wind power side. Currently, Korea produces 1.9 gigawatts through wind generation. So based on the 11 basic plan, the goal for 2030 is to increase to 18.3 gigawatts. So it was increased from 10th basic plan. And the goal for 2038 is 40.7 gigawatts. So current figure is 1.9, but we only have 16 years, so we'll have to increase by 40 gigawatts, so the goal is quite high. So fortunately, we have a chance to develop offshore wind power plants. And we have 86 projects, and we got the business approval for many projects out of 86. So I think the goal of achieving 40.7 is achievable, but still it's challenging. Korean Peninsula is surrounded by ocean, and we have good wind condition, and I think most of the wind power will be generated offshore. If you look at Korean Ocean, south and west, we can use fixed power wind power plants. It depends the situation by country. Some countries use fixed type wind poweration, and some countries use floating type power generation. Some countries prefer to use fixed type for offshore power plants, but some other countries prefer floating type. It depends on the environment of the country. If you see the East Sea of Korea, we have a good sites for floating structure. We have many projects for the floating wind power generation that can produce more than 6 gigawatt in total. Let's look at the value chain and technology for floating offshore wind platform. Let's look at the value chain by tasks. Development phase, construction phase, operation phase, and deconstruction phase. We have different elements that goes into this phase, but for today's presentation, I will focus on construction and maintenance phase. In the construction phase, the important element is the turbine itself, cable, and other auxiliary equipment that goes into that turbine. So the floating offshore wind farm is not entirely commercialized. So it is difficult to tell you the exact capex. This is just a pre-commercial stage, so we have some experience in the pre-commercial stage. Then the biggest part comes from substructure, and followed by turbine. So two of the biggest elements that contribute to the price is substructure and turbine. So if you look at the turbine part, there's many proof of concept tests around the world. If you see the capacity of those turbines, they are below 10 megawatts, but in going forward, for the wind farm that will be built in the future, the turbine size is around 15 megawatt level. And currently, many countries are developing 18 megawatt turbine also, but for near future, we'll see the application of 18 megawatt wind turbine.
And the second component is a floater. So there are spar and also barge, semi-submersible, and also tension leg, the typical parts and typical types of floater. Semi-submersible, meaning that half of its structure will be underwater, and also semi-submersible. As you can see, not 4 columns, there are only 3 columns. So development for this 3-column semi-submersible is underway. So among 4 different components and 4 different types of floater, which one is mostly commonly used? So semi-submersible structure is highly likely to be used commonly. So when I first started to develop the floater, it would be the best if we can develop all different types at the same time, but we had to prioritize for development, for efficiency, and semi-submersible will be highly likely used. That's why we focused on the development of this type first. And there are many different types of the structures which comes under the pilot development. And in the EU, most of the feasibility has been done for the floaters, and the company called Ikinori started to test the feasibility. It's called a high wind, and the type is a spar, like a long pole. And the size of the feasibility was 2.3 megabytes, and also the scale has been gone up to less than 10 megawatts. So it has a spar type and also barge types, semi-submersible type, and also semi-Jun PLT, all the way to TLP. Many different types of floaters come under pilot project. And again, semi-submersible is commonest type. There was a very important feasibility done, so I would like to mention about that. So semi-submersible, equivalent to 10 megawatts. There was a construction, for example, Kinka White, and also high wind Tampen. Its size is 8.6 megawatts and 11 of them. So now it is entering into the pre-commercial stage. And in Asia, in Japan, there's a project called Fukushima FOWT. Many feasibility has been done. And the last one, we can see many of them happening in China, 2021, 22, and 23, and 2024. So every single year they are carrying out feasibility. And the types of the substructures are, again, mostly semi-submersible. They first started to test 5.5 megawatts and 16 to 6 megawatts, meaning that they have two of the structure, which generates 8 megawatts. So they are carrying out this feasibility to prove the performance of the structure. I have told you about the turbine and structure, and one of the very important the component is mooring. So normally wire chain are used for mooring, which is commonly used, especially plain catenary type. And in order to reduce cost, and also in order to really reduce the load, synthetic rope is used. When we use a synthetic rope, that will reduce the load, weight, but more feasibility needs to be done. So there's still ample room for us to explore technology. And as a part of our efforts to reduce the CapEx, new mooring lines are being introduced using new materials. And there are many interesting ideas. For example, there are many different types of floaters using different technologies. So maybe we could think of sharing different mooring types by having many anchoring points which connect different floaters. And also we can come up with an idea that will reduce the anchoring point, but we do know that this is a relatively innovative idea, so it will take some more time to further develop. So there are technological issues around the number of lines that we are going to have for the marine structure. FPSO, the number of lines is normally 16 and also 24, normally less than 30. And for a floating wind farm, especially which generate 500 megawatts, we need to have like more than 30 floaters. So in the number of lines, we will probably have more than 100 lines. But if we can reduce the number 6 to 3, then that will halve the total number of lines, right? So the number of lines is very important. And also there could be a damage condition which can cut cables, and we have to set the risk level appropriately. So meaning that we have to reach a consensus among the developers and also designers. So cable is one of the very important element and component. And as we're talking about floaters, cables are also dynamic. We do have dynamic cables. In order to protect the cables, we have to think of how we are going to design complication of whole picture to protect the cables. And in bigger picture, we'll have to think about how best we can form topology to seamlessly connect these cables each other. So in developing the floating wind farm, one thing I would like to emphasize is a port. So turbines, floaters, mooring, and cables. It can be supplied through the supply chain, mainly led by the private sector. But to go deeper, for example, yards and quayside and also port, I think this is infrastructure which requires policy support. We need the space to manufacture floaters, and also there are all other parts for like turbines, so meaning that we have to have a storage to store them, and we have to also make sure the land is firm enough to resist the load. So sometimes geologically we cannot have yard and also cliff at the same time. So we have to carefully examine the topology, and for manufacturers and also repairers and so on. And regarding O&M, floating wind farm is not yet commercialized, so we need more experience on large scale floating wind farms. So there are many ideas to reduce and to minimize O&M, but we have to talk about it once we get enough experiences on large scale floating wind farms. And it is the best if we can do O&M on a fixed site, unless we will have to carry it to the port and do the O&M there. So we will have to wait and see, and we will have to have more data on how we are going to do the O&M on floating wind farms. And the characteristics of the solar power and the wind farm is that there is no consistency in terms of the electricity production. Solar power is largely dependent on the sun, energy of the sun, and also wind farm heavily relies on the timing of the wind blowing, and sometimes the grid might not be able to absorb all the energy. So in order to optimize the grid, we have to probably have energy storage, and then sometimes some of the energy needs to be transferred and changed into hydrogen. So I think energy storage is very important for battery energy storage system, hydrogen industries. So when the facility is in land or in the ocean, it could be in a cluster, it could be scattered. We'll have to think about how we can connect this grid for different energy sources, either locating in land or in the ocean. I think that will be a very important decision to make. So till now, I have laid out to you about the elements around a floating wind farm. And other than that, I would like to talk to you about the efforts that we are making for ocean transformation. So HG Hyundai Group back in 2022 at the CES in the US, we have announced the vision for ocean transformation, and we announced that for sustainable future growth, it is necessary to realize the infinite potential of the ocean, a valuable resource of mankind. And as a sub-vision of the ocean transformation, we announced the ocean mobility, ocean wise, ocean life, and ocean energy. Among them, ocean energy is all about how we are going to utilize ocean ecosystem. So as a part of realizing this vision, we have developed our own floating wind farms, and I've been talking about this repeatedly from the beginning of my presentation. This is developed by ourselves, and the model is called HyFloat. So we have developed our own floating structure, which is called HyFloat, and it is actually applied to the field. So for the first time, this was applied to the construction company back in 2021. 8 megawatts turbine came under the feasibility project, and our structure was chosen for this pilot project. And also in the east, there's a GW3 project and also Haori 3 project. In 2023, all these projects chose our structure and became part of the construction. Of course, it is somewhat different to substructure project, and also the basic plan for the transformer is done by ourselves. So for the construction of the basic plant, we are supplying our model. This HyFloat model has excellent performance in mobility, and especially, for example, loading this structure, the site near a cliff. So not only the operation, and also it is excellent in its manufacturing as well. So let me move on to the development history. So about 15 years ago, we first started to research about this structure, especially floating wind farm. Back then, the research first started off for the technological development and going beyond the engineering. We targeted that we need to make it as a product from year 2018. And we also decided to further refine the structure enough to be commercialized in the market from the year 2020. And the HyFloat, which can generate 10 megawatts, we developed this HyFloat, and also we examined our model. So about this central model, we have central types which generate 8 megawatts, 15, and also 18. And for the eccentric type, we have 8 megawatts. So let me talk to you about our floater design technology. So I told you that this is very unique and also very first floater domestically developed and also applied to actual construction. And not only that, we thought that it is very important whether we can customize our engineering to the needs of consumers. So we evaluated the load and also designed mooring and also manufacturing. So we have our own technologies to do all this. What's important is that in the process, oil and gas corporation also provided us with their technologies. So I think we have great strength as a nation, that we have a great technologies accumulated over the shipping industry. This is quite a new area, not only about the hull, but the interface with the turbine is very important. So this is a very new area. So the turbine companies, substructure manufacturers, and also designers, they need to really cooperate with each other very well. So let me go back to technology as well. I told you that we could utilize existing technologies, for example, environmental load, and also designing the parts, mooring, designing cables. Oil and gas has experiences on this, and we could use their technologies for all of this, and also turbine and interface was new to us. So in the future, success and failure of floating the wind farm is dependent on the cooperation with the turbine manufacturers and designers, and also how competent you are in also having such technologies. So I told you that we first started to develop this from 2010, and also we have utilized technologies from the Oil and Gas Corporation. So we already had experiences from 1976 when we first started our business on this, combining with the technologies from Oil and Gas Corporation. And not only that, I think definitely Korea has a great strength in the shipbuilding and shipping industry technologies. And as you can see from the photo on your right-hand side, upper hand, there are so many experiences accumulated, just like the iceberg below the water. And this can be likened to domestic companies which holds competent technologies. So please allow me to conclude. Renewable energy is much needed to respond to climate change. And the greenhouse gas emissions are there in the process of generating energy like electricity. So we are making efforts to curb the temperature increase within 1.5 Celsius degrees. And this was released in the early this year. And we are making efforts to curb the temperature 1.5. But I think we are reaching our limit because it is reported that we are reaching 1.45. And I think that's what happened during the summer this year. And the Guardian interview was very interesting, I think. They asked 380 top climate scientists what they felt about the future in May 2024. So they are the ones who participated in IPCC report. So they are top scientists in climate. And 77% of respondents replied that at least the temperature rise will be probably 2.5 Celsius degrees, and almost half of them said that the temperature increase will be probably more than 3 Celsius degrees. Nonetheless, the efforts that we are making, we really have to ask ourselves whether we are making our really utmost efforts, whether we are really sparing any effort. And I would like to also tell you there's a hope, because according to the IPCC, we can turn things around if we act fast and collectively. Of course, there are conditions to be met. International cooperation, knowledge sharing are important, and as engineers, I think we can contribute ourselves to these two. And this is my last slide. So from the HD Hyundai group, we have this slogan for ESG management and also to respond to climate change. Our vision is this: beyond blue, forward to green. So we are sparing no effort to go forward to green and also to emerge as a green company, an eco-friendly company. I think these efforts are not just made by us, but all the companies in the shipping industry. Domestic shipping industry is definitely making its utmost efforts as three sides of Korea. We are having an upper hand to become more and also greener.